Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math, and today we're going to learn about differentiation of natural logs and exponentials. We're going to differentiate each function with respect to x. So, if I was given this function, y equals the natural log of x to the third power. Well, when we take the derivative of a natural log, okay, what we want to do is we take our dy, dx right here equals. Now the derivative of natural log of u of some function with respect to x is 1 over u times u prime. Okay? So we have 1 over the inside is x to the third power, 1 over x to the third, and now we can take the derivative of the inside. Derivative of the inside x to the third using the power rule here is 3x squared. Okay? So we can simplify this a little bit from here. So we've taken the derivative, but now let's simplify it. Well, the x squared and the x to the third, we can cancel out these exponents, right? The third power becomes the first power, right? Get rid of that, and then we eliminate x squared really from there. So we're left with this 3x, and there is our final answer, our derivative. Y equals e to the 2x to the third power. Okay? Well, we're taking the derivative here with respect to x. We have dy dx. We're going to apply our rules of exponentials with derivatives, and we're also using chain rule, right? So we have e to the u is equal to derivative of e to the u is e to the u times u prime. So we kind of repeat what's already there. First, we have e to the 2x to the third power. Now we need to multiply that by the derivative of the inside, what's inside that exponent, right? The power rule says the 3 comes down. Well, 3 times 2 is 6, so we have a 6 right here. Exponent gets subtracted by 1, and we have it squared. Now, it's pretty simplified as it is. You could rearrange 6x squared out front, up to you, but chances are when you're doing derivatives in the future with this, that something might cancel out, and so rearranging isn't always necessary, really. But we keep it as such, pretty good here. Let's see anything more I can really simplify. So that is our final answer. Y equals the natural log of 2x to the fourth power. Now, to see this, with parentheses to help show the order, right? We have the natural log of 2x to the fourth, and then we have the natural log of the natural log of 2x to the fourth. Okay, so we're going to apply derivatives with natural logs as well as chain rule a few times here. So we have dy dx here. Okay, dy dx. Well, it's equal to the natural log, right? We take the derivative of natural log, it's 1 over u, what's on the inside. So we have 1 over the inside, which is just this part now, the natural log of 2x to the fourth power. And I'm not going to put the parentheses there, we can see that, times the derivative of the inside. Now, the derivative of the inside is involving this natural log. Derivative of natural log is 1 over, right, what's on the inside. So again, chain rule, we have 1 over the inside, which is 2x to the fourth power, times the derivative of the inside, derivative of 2x to the fourth power, comes out to be, well, 2x to the fourth power. Power rule comes out. 4 times 2 is 8, so we have 8 now, x to the third power. Okay, so multiply that, and if you want to put it over 1, keep it all symmetrical or nice and neat here. Symmetrical, but there we are. So now let's simplify this, okay? And when I'm seeing with simplification, I know I can get rid of x to the third, x to the fourth right there, right? So x to the third can be eliminated, and 4 turns into 1, okay? 1 power. 8 and a 2, well, 2 gets eliminated, 8 becomes a 4. And so pretty much there, I'm done. We just have a 4 that's left over up top, so we have 4 over. Okay, and if we want to put the x out front, we can. That's just what's left there. So we have x now, natural log of 2x to the fourth power, and we have our final answer. Y equals the natural log of 3x to the third power. Now you might see it like this, but what we really are doing is the natural log of 3x to the third power, and the natural log of the natural log of 3x to the third power. If you want to put parentheses in, it really helps see what's going on. So we're applying the chain rule twice with some natural log rules as well. We have dy dx right here is equal to, well, the derivative of natural log, right, of whatever the inside is 1 over the inside. So the inside here is just this natural log of 3x to the third power, natural log of 3x to the third power, times the derivative of the inside. Well, the derivative of the inside involves another set of a chain rule, okay? Natural log of that inside, we have 1 over the inside. So 1 over, this could be 1, but a straight line now. 1 over 3x to the third, times the derivative of the inside, derivative of 3x to the third. 3 comes down, 3 times 3 is the 9, and we have x, subtract the exponent by 1, which gives us x squared. We can put it over 1 to help maybe see it a little nicer, but there we have it. We've taken the derivative. Now at this point, it's just algebra, and we are simplifying. So we have equal to, well, 9 and 3 goes into 9 3 times, right? So we cancel that out. We go to the 3 right there. And the x squared cancels out here with x to the third. We get rid of the third exponent. So now we just have 3 over x there. So our numerator is only a 3. Let's put the x out front. X times, and what's left over here? Natural log of, let's write the 3 there. It's getting all funky, but of 3x to the third power. And there we have it, our final answer. Y equals the cosine of the natural log of 4x to the third power. Now, if you want to see it with parentheses, we have natural log of 4x to the third, and the cosine, we're taking the cosine of the natural log of 4x to the third power. Okay? So, from there, we need to derive this and then simplify. So we have dy dx, and we're going to apply the chain rule with natural log rules, trig rules, power rule, log rules, right? So, first things first, we start on the outside. The derivative of cosine of x is negative sine of x, right? So cosine of u is negative sine of u times whatever u prime is going to be. So we have a negative sign now, and we keep the inside the same. Natural log of 4x to the third power. Okay? But now we need to take the derivative of the inside. Well, the derivative of the natural log of 4x to the third is 1 over 4x to the third times the derivative of 4x to the third. So we have 1 over the 4x to the third here. But now we need to multiply that by the derivative now of 4x to the third. Okay? Derivative of 4x to the third, power rule, 3 comes down, multiply by 4 gives me a 12. And we have x squared. Okay, we subtract x by 1. And there we have it. Okay, we've taken the derivative. So now at this point, we just need to simplify. Okay, so let's do some simplification. X squared and x to the third, right? We can cancel that out and just have x in the denominator. 12 and the 4, simplify 4 to the 12 3 times, we have 3. Okay, so let me rearrange this and put the 3 out front, or negative 3 in this case. We have negative 3 times the sine, right? Sine of natural log of 4x to the third, all over what's left in the denominator, which is just x. At this point, we've pretty much simplified it, and we have y equals e to the 3x squared power. All right, double exponent here, right? Well, what I want to do, I'm taking the derivative here. Okay, we're going to use rules of e to the u as well as chain rules. So if dy dx is equal to, well, derivative of e to the u is e to the u times u prime. So let's repeat what's written. E to the 3x squared times the derivative of the exponent. Well, our exponent is e to the 3x squared. So the derivative of that, e to the u, is just repeat. So repeat the exponent, e to the 3x squared times, well, the derivative of that exponent now. That exponent involves the power rule. 2 comes down, 2 times 3 is 6, and we have 6x. Subtract the exponent by 1. 2 minus 1 is 1, so we leave it as is, right? So at this point, we actually can simplify a little more, okay? The 6x we can put out front, so the 6x here, and then we have times e to the, we have e to the 3x squared power, but then when we have the same base, so we have the same base here, we can add these two exponents and put it in one big power. So this is really another power of, or we add the powers of 3x squared. So we can have a final answer now. You can see it here. It's 6x times e to all of this being the exponent, e to the 3x squared plus 3x y equals e to the exponent of 4x to the third plus 5 all to the second power, right? Or the exponent to the second power. All right, so let's take the derivative. Well, we have dy dx is equal to derivative of e to the u is e to the u times u prime. So we keep everything the same. E to the 4x to the third plus 5 all squared. So from there, we need to multiply that by the derivative, the exponent. Well, the derivative of the exponent involves a chain rule and power rule again. 2 comes down up front, times we keep that inside parenthesis the same, 4x to the third plus 5. And we subtract the exponent by 1. Well, 2 minus 1 is 1. We don't really need to write that there. Multiply that now by the derivative of what's inside that parenthesis, okay? 3 comes down, 3 times 4 is 12, so we have 12x squared. And then, we really don't need to, right, subtract the exponent by 1, squared there, but we don't need to take a derivative or write it down because the derivative of 5 is 0 plus 0. We're done now, okay? So now let's just simplify this a little bit, and then we're pretty much done. So, what I'm going to do is I'm going to multiply, well, the 12x, okay, times the 2 comes out front. So the 2 times 12 is 24. Let's bring the x squared out front, times, we just bring down the rest, e to the 4x to the third plus 5, and all that squared, times 4x to the third plus 5, right there. Now, it's up to you if you want to put that out front or how you want to write it, but since it's all multiplication, just keep each really section together, and it'll be fine. But again, this is our final answer. Y equals natural log of 4x squared times, parentheses here, negative x to the third minus 4. Okay. Well, what we're going to do, okay, is we're going to use the product rule, chain rule, and log rules. Okay. So we have dy dx here. Okay. Well, we have what we're going to do. Take a derivative, keep the front times the derivative of the second part. So we have natural log of 4x squared times the derivative of the second part. Well, 3 comes down, right? Negative 3x squared, and then derivative of negative 4 is 0, so we'll leave as such. Plus now the second part, negative x to the third minus 4, times the derivative of the first part. Derivative of natural log of u is 1 over u times u prime. So we have 1 over, what's on the inside? 4x squared, times the derivative of the inside, power rule, 8x, right there. Right? We can put it over 1 if we want. Okay? So we've taken the derivative now. Everything else from here is simplification. So 8 and the 4 simplify just to be a 2, right? 4 goes to 8 2 times, and x squared and x cancel out, so we just have x down in the denominator. So we have 2 over x over here times this, and we have that plus sign over here. Let's try to make it one big fraction here over x. Okay? So the x in the denominator, so we're going to multiply this side by x over x. To do that, right, we already have the x down here counts as being divided by x, but to bring it to the fraction, we multiply this part by x. Since we have x squared, we just multiply that by x, and it becomes x to the third power. Put that up front, so we have negative 3 x to the third power times the natural log of 4x squared. So we got that front part taken care of. Now, here's the tricky part. Multiply that 2, right, we're adding this, we're also multiplying by that 2 to both parts. So we can distribute that 2 in. So we have a minus down front, minus 2x to the third, and then 2 times the minus 4 is minus 8. And there we have it, our final answer. Negative 3x to the third times natural log of 4x squared minus 2x to the third minus 8, all over x. Now remember, x was underneath all of that, okay? Y equals natural log of negative 4x to the fourth power over x to the third minus 3, and all that's going to be to the fifth power. What I'm going to do first is actually simplify this, okay, using our rules of logarithms, right? 5 can come out front, actually, here, and don't need any exponent. That's one of the rules of simplifying logarithms. Natural log of, and keep the inside the same, negative 4x to the fourth over x to the third minus 3, okay? From there, okay, now I'm going to take the derivative of that, and I find it a little easier. So when I do that, we have dy dx equals, that 5 is a constant that's going to be out front pretty much the whole time. Okay, let's leave it out there. And now we're going to take the derivative of this part here. Well, derivative of natural log is 1, natural log of u is 1 over u times u prime. Well, we're doing 1 over this fraction. Essentially, we're flipping that fraction. The negative stays out front. And to flip it, we have x to the third minus 3. Numerator and denominator is 4x to the fourth. Now we need to multiply that by the derivative of the inside. Well, the derivative of the inside, well, it's a fraction. We need to do the quotient rule. So I'm going to leave that negative just out front here. So it's multiplied by a negative. And we have our quotient rule here. Quotient rule has the derivative of the numerator. So derivative of the numerator, 4x to the fourth power, is 16 x to the third times the denominator, x to the third minus 3, minus the numerator stays the same, 4x to the fourth times the derivative of the denominator. Okay, x to the third comes down, well, power rule, we have 3x squared here, and we don't need the minus 3. All of that is over the denominator squared. Okay, our denominator squared here is just x to the third minus 3, all squared. And there we have it. Make sure we bring our bracket down because 5 gets multiplied by all of this. Now, let's simplify this slightly. See what we can do. Maybe cancel out a little bit. But I'm just going to combine it in a fraction, leave the 5 on the outside, and just kind of go from there. So we have dy, I'll rewrite it this time, dy dx equals 5 still stays up front. Okay. Now, since we're multiplying these two fractions, we just kind of can combine them. Okay. So our denominator, I'm just going to write to be that, well, 4x to the fourth power times x to the third minus 3 squared. And then, well, here's the tricky part. We have a negative times a negative, which is just a positive, right? So we kind of can eliminate that right there. Two negatives cancel. So we'll just kind of separate this, our two parts here. We have x to the third minus 3. Well, look at that, right? We've multiplied these two, x to the third minus 3 with x to the third minus 3 over here. So essentially we can simplify that and actually change this to be the first power, right? And we can eliminate that x to the third minus 3. So we have that canceled out, which is nice. Then, that's canceled out. We don't need that anymore. We have this 16x to the third up front. Well, 16, right? So we've eliminated this. I'll kind of cancel it out, right? We eliminated that with this part here, right? Being multiplied. And then 16, well, 16x to the third, we have 4 down here, right? But this one's a little tricky on what we can actually eliminate, right? Because this part isn't really right. We're multiplying it. We were distributing this thing to both the x to the third minus 3 to both parts there, so we can eliminate it. But here it doesn't directly go because there's that minus sign there. So actually there's no simplification really that can go between these two. Perfect. So we have just, well, 16 x to the third times x to the third minus 3. And then here let's go minus this. Well, let's multiply this out. Okay, 4 times 3 is 12. And then x to the fourth times x squared, we have x to the 6th power. And then bring that out front. There we have it. Our final answer, our final answer here is kind of a large fraction. You probably could simplify a little more if you really wanted to, but I'm fine as it is. It's 5 times, in our big bracket here, 16x to the third times x to the third minus 3, minus 12x to the 6th, all over 4x to the fourth times x to the third minus 3. Y equals a fraction of e to the 5x to the fourth power over e to the 4x squared plus 3 power. Okay? Well, first thing, you don't want to just jump in right now and try to use maybe the quotient rule of this. You could work, but let's simplify this a little bit. Okay? Our rules of exponentials allow us to keep this as we have the same base of e. E to the exponent, we just subtract the exponents. 5x to the fourth power minus 4, now let's keep this in parentheses, 4x squared plus 3 power. Okay? Now you can distribute that minus sign to make both of these a minus. I'm fine with whatever you want to do. Okay? So now, okay, and actually, let's go do that. That might be a little easier to see. So I'm going to rewrite that here. Let's rewrite that here. So we have the minus, that denominator, let's distribute that minus sign across. So we have minus 4x x squared minus 3. Okay? So let's simplify this, right? Or let's take the derivative actually. So dy dx here. Right? Well, our rules with derivatives, right, is e to the u times u prime. Well, we have e to the 5x to the fourth minus 4x squared minus 3 power times u prime times the derivative of that exponent. 4 comes down times 5 is 20, x to the third power, and then minus here, 2 times 4 is 8, 8x. That's it. The 3 don't really worry about because the derivative of negative 3 is 0. And at this point, I'm pretty much done. I would say it's most simplified as is. That's it. Okay? Where our final answer is e to the 5x to the fourth minus 4x squared minus 3 times 20x to the third minus 8x.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.